Metallographic, sample preparation of aluminum alloy coating. The core difficulty lies in the large difference in hardness between the substrate and the coating. The aluminum substrate is relatively soft, while the coating is relatively dense and hard. It is prone to coating-edge chamfering, peeling, scratches, and tissue artifacts. The entire process must be controlled around the principles of reducing mechanical damage and ensuring clear interfaces. The specific precautions are as follows. When sampling, the coating must be facing upward and the substrate downward during cutting. The cutting direction should be as perpendicular as possible to the coating plane to minimize geometric distortion and stress at the cross-sectional edges. In the embedding stage, to avoid thermal stress and pressure from hot pressing embedding damaging the coating structure and interface, priority is given to the cold mounting process. Choose epoxy resin with high hardness and excellent edge protection such as TJ2568 to form rigid support and protection for the coating in subsequent grinding and polishing processes. Weigh accurately according to the weight ratio of resin to curing agent of 4.5 to 1. Mix the resin and curing agent thoroughly. Stir continuously for 2 minutes to ensure uniformity and reduce the introduction of bubbles. Slowly pour the mixed resin into the mold where the sample is placed. To eliminate internal bubbles, improve the density and transparency of the resin. The mold is placed in a pressure cooker for pressure curing. After curing for about 2 hours, demold it to obtain an embedding block that is transparent inside, free of bubbles, and completely covers the sample. Grinding and polishing. Adopt Trojan new 4-step metallographic sample preparation method with the specific steps as follows. First, use P400 sandpaper to smooth the surface. The purpose is to quickly obtain a flat global cross-section and eliminate cutting marks. This step must ensure that the sample is evenly stressed. Step 2. POS polishing disc plus 9 micrometers, polycrystalline diamond polishing slurry. This step aims to efficiently remove the deep scratches and deformed layers left by P400 sandpaper. The third step, SC polishing cloth plus 3 micrometers, polycrystalline diamond polishing fluid. Further remove the fine scratches from the previous step to prepare for the final mirror finish treatment. Step 4. ZN polishing cloth plus 5 OMM silica polishing solution. This step aims to completely eliminate all minor scratches. Obtain a real surface with no deformation and high reflectivity for microscopic observation. After the 4-step process, the surface has become as smooth and shiny as a mirror. Place the prepared mirror-like samples under a metallographic microscope for observation. The aluminum alloy matrix, the nickel intermediate layer, and the tin surface layer can be clearly observed. The interface is flat and sharp, with no sample preparation defects such as chamfers, peeling, or cracks. Proved the effectiveness of the aforementioned sample preparation process. The core role of pre-nickel plating before tin plating on aluminum alloy is reflected in 2 aspects. First, it can efficiently block the bidirectional atomic diffusion between the aluminum matrix and the tin coating. Avoid the formation of brittle intermetallic compounds at the interface to prevent embrittlement, failure of the coating. Second, as an adaptive interface transition layer, provide a uniform and stable adhesion base for the tin layer, significantly enhancing the bonding strength between the tin coating and the substrate.
Trojan. Discover the truth of material.